All right, so let's try to understand the concept behind the number of negative and positive real zeros. In the first place, when you're doing polynomials, this is a man named Rene, the French say Descartes, Rene Descartes, and he was a mathematician and a scientist. So his rule basically says if a polynomial function is arranged, they're arranged in descending powers of the variable. If the number of positive real zeros of p of x is the same as the number of changes in the sign of the coefficients of the terms, or is less than by an even number, then it's a polynomial. Old smart man who complicated things when it came like this to math, because he was extremely smart. And extremely smart people complicate things, which is why I'm going to try to make this easy, because I'm not extremely smart. I'm mildly. The number of negative real zeros of p of x is the same as the number of changes in the sign of coefficients. Okay, enough of that aside. These are your degrees, and like Rene Descartes said, it went from degree of, this is a fifth, this is called quartic or fourth, this is a third, this is a second, and this is really a 1. It's not a 0, remember? It's not that. Okay, so you're going to count the number of changes in the signs now, and remember it's fifth. Now, here's the situation. From the fifth power to the fourth power, and you're looking at the coefficients. Okay, coefficient, count the number of changes in the signs if p of x changes. Okay, so if it changes. So from 4 to 3, 0. 0 changes. From 3 to 2 is 1, negative 2. And from negative 2 to here is 1 change. And from here is a negative, that's another change. And from a negative to a positive is 1 change. So we have 1, 2, 3, 4 changes. So in your first column, you're going to put 4. Okay, now what are you going to put? That's the number of positive real zeros. Okay, for the number of negative real zeros, we're going to go on and get into our next slide. You had a negative 4 here. A negative 4 to the fifth power is going to be negative because it's odd. So you have negative 1, or you say x, because it's p of negative x. That's a Descartes rule. So you have negative 4 times negative 4 is positive, times a negative is a negative. And don't worry about this. You don't have to multiply the coefficients, because this would be 16 and that would be 64. Don't get into that. That would be 256. Don't get into that. So this is right here. A negative times a negative I put here is a positive. Times this negative is negative. Times this okay, this negative and this negative is positive. This one is a negative, and this one here is going to be a positive. And over here is going to be a negative times a negative. So this is one negative number. So real roots is going to be 1. So in that column where you had 4 and 1. Now listen. 4 plus 1, because of the degree of polynomials, has to add. 4 plus 1 equals 5, yes? So when you get ready to write in your columns, and your first column is going to be positive, next column is going to be real zeros, next column is going to be imaginary. You have 5 degrees, they all have to add up. So this is your first column is going to be 4, you're going to be 1, and this is going to be 0. Why? Because this already takes care of this 4 plus 1 already takes care of this 5. Okay, then when you move on and you get ready to, there's a total degree of 5. Just look at what this is. It's 5. And when there's a total degree, according to Rene Descartes, you either have total zeros or imaginary zeros are going to be 0, 2, or 4. So when we get ready to look at our chart, we had positive zeros from the first one. Our chart was here. It was 4 plus 1. It has to be 0 because 4 plus 1 is 5. When you had 2, or if you had 2 positive real zeros, your 2 plus 1, you have always, this whole column is negative real zeros because we've already done the math. So that's 2 plus 1 is 3, plus this 2, it has to be, is 5. And then if you had 0 positive real zeros, 0 plus 1 is 1. This has to be 4, because 1 plus 4 equals 5. And I did this. Okay? So look at this. This side is 4, 2, 0. This is all ones, and this is 0, 2, 4. So this side is going down 4, 2, 0, and this side is going up. This side is going 0, 2, 4. And that's really all there pretty much is to it. Just think about this, and if you can remember to add this, and go back and do your number of positive zeros, starting from your change from here to here is 0. From this coefficient is positive, this one is negative is 1. This is negative and this is positive, so there's a change. This is positive to negative, that's 1. And even though this is a constant, this is negative to 1, that's positive. So it started with you at 4. Let's suppose this equation was 4x plus 3x plus 2x cubed, of course, I'm sorry, that's not a 2. I'm thinking down. This is a 4. We are almost done. 4. That's a 5. And this was negative 5x squared. And this was negative 6x squared, or negative 6x without the square, and this was negative 1. Look at your changes. 0, 0, here's 1 change, 0 changes, and then from here to here, 0. So you would have had negative real zeros here. You would have had a positive real zero of 1 here. It depends on how the equation is written. But for right now, you look at what you have. Most of your teachers are probably going to give you Rene Descartes Classic, where you're going to either have 4, 2, or 0, because that's his formula. And look at how they're added together. Thanks for watching.